I'm Marley Gray with Microsoft, and I've set this talk up to be about machine learning and data and some of the things that you can expect to be able to do, particularly around payments, and probably go through an introduction and talk about the rise of machine learning, how this stuff actually works, make it sort of approachable so that you can think about ways that you could implement this in your business, to look at cost reduction, reduce fraud. Most people always say, how do I make money off of this? Not just cost save, but what are the opportunities? And particularly in the payment space, there is a lot of opportunity for making revenue off of that data if you can get away with it. So let's talk about machine learning. So the speed of business acceleration. So we have this convergence of massive amounts of data that we can store in the cloud. The data's always sort of been there. We're generating more and more every day. The problem has always been, where do you put it where you can reason over this data in any meaningful way? And the data is always in weird formats, right? You have these different payment formats, different standards. Some of them are really old and not very rich. And some of that data you could then correlate to richer data if you just have the tools to do that. So the cloud brings very low cost, massive amounts of storage, and the ability for you to take your payments data and correlate it with other data sets to derive other insight and revenue, and also avoid risk. So we're going to talk about how these three things come together. First, let's talk about the move from reactive to proactive action. So the first thing that you'll see is, we want to move from, hey, what just happened to me, to and this whole reactive process that we go through, and move to more a proactive model. So at Microsoft, we've been at work for, some people call it artificial intelligence. We sort of separate the two. We're not quite at a sentient AI level yet, but we are building machine learning domains. And I'll talk about what machine learning does. But we've been doing this for quite some time, everything from predicting the World Cup to NFL games, and surfacing this up through various properties, whether it's through Bing. But we're largely putting this underneath a brand called Cortana. So Cortana Analytics takes many forms. Cortana is this, if you're not familiar with video games, in the Halo series, Cortana is this AI that follows our protagonist around to inform him of things in timely manners, like where bad guys are, remind him who key players are, update him on, contextual aware data, which is so we've taken that brand and we're going to ride that pony, if you will, because everybody loves Cortana. But we'll surface Cortana. That's sort of the human interface that you'll have. You'll have it on your phone, you have it on Xbox, you have it on your computer, and we have it on the cloud. But we also have Cortana Analytics Services. That's what we're going to focus here. It's Cortana Analytics Services in the cloud. What can you do with this hyperscale model, and how does it actually work? So we have a couple of reference implementations that are novel. Some of them are actually very powerful. So we started a project several years ago combating child pornography. And we used our machine learning AI to go out and scrub and go through the internet to try to identify, using something called PhotoDNA, that would look at different photos to see if it could identify what was child pornography or not, and to take action. And that service became very popular. In fact, most of our competitors like Google, Yahoo, and the like have actually used that service to try to combat, something that's, just to weed out bad actors, and then have law enforcement be able to take action. We also then took some novel things. We did that, I don't remember if that Twins or not, where you would post, you could post or guess my age. We had a website, some researchers just say, hey, let's put this up, and it was using Cortana in the back end. So Cortana has the ability to reason over visual data as well. So photos, videos, and she can identify things, make guesses. So the how old am I? You would send a picture of like a bunch of friends, with arms around each other, and you would get funny results. Some people would look, spot on. They'd get their age. Some of them would look like seriously old, and some would look really young. So it's more of a comical thing. But then the second one was twins or not, which was you would post two pictures of the same person, and Cortana could tell you whether or not that was just the same person at a different point in time, whether they gained some weight or lost some weight or had aged. It didn't matter. Or if it was their identical twin, which I found to be completely fascinating, which was really cool. The second one, this last one is probably the one that everybody gets, especially the Star Trek fans, where Skype has the ability to do real-time audio translation. I don't know if you've seen that video of the school kids in the U.S. and a classroom in Mexico, and they are looking at Skype visually at each other and speaking to each other, and it's translating real time, English to Spanish and Spanish to English. I'm going to talk to you exactly how we did that. That's actually fascinating to go through. But before we do this, these slides didn't quite format. They wanted to put it in their format, so forgive some of the awkward coloring here. But the major components that we have here is we have data. You have lots of data of any format and shape and size. So if you think about your payments data, your transaction data, you'll have message types and transaction types that usually aren't that rich in nature. But we can also pull in market data. You can pull in news data. You can pull in all sorts of behavioral social networking data. Really any kind of data you can think of. And as long as the story with this is no data is irrelevant. No matter how trivial it might seem or how big or cumbersome it might be, it is something that we can reason against and hopefully include your success rates. So we do this through something called, there's some tools here, the Data Factory is a big old, if you're familiar with ETL, ETL is the process of taking data in one format and saying, oh, let's convert it to this. So Data Factory does things like you can point Data Factory at places where it can go fetch data and pull it in and scrub it into a format and do that automatically at a massive scale and dump it in these things called data lakes. And I'll show you what data lakes look like. And these data lakes are not just your own private data lakes, but third-party data lakes. So the government publishes cloud data in our cloud. We have market data providers publishing tick data and news data up into the cloud. So you can have references to those and include that data set into your reasoning and learning set. So the storage is both your own storage and third data stores that you're referencing. And then the analytics is the machine learning. And we also have this thing called stream insight. So you might have data that's coming in real time. So this is typically thought of in the Internet of Things type of paradigm where you have these devices sending events in real time into your data store, and you need to be able to, and market data is another indicator as well. You could do real-time payment data through stream analytics as well. And then the all-important human interface, how do we make sense of this, are the pieces. So if we put these things in a stack, so you see sort of the data input pieces, so you have business apps, custom apps, sensors, and devices. All of these things, from a payments perspective, you're going to touch every one of them. But you're going to be inputting data there that's going through these data factories and going into this big data store, and then we have these processes behind it. And then ultimately we're going to be feeding that data to humans in readable format or to other automated systems or systems of intelligence. So let me step back a little bit and tell you about how this works. So machine learning works roughly like this. You get a large set of data, and what you do is you carve out a small sliver of it, maybe a 1% of your data, and that becomes what we call your training set. You take Cortana and Cortana Analytics and you say, Cortana, here's your data, answer the following questions. And you actually quiz Cortana on that data set. And you quiz her and she goes and she evaluates it, and you can come back and she comes back with the result set. And the result set you come back with, you say, usually she gets about 60% of the questions right. But when you score it and you tell her, you got these wrong, you can also say what the right answer was, she learns. So the next time she goes over the training set, she gets it into the 9s. And you can continue to refine it and refine it and refine it. And so, at some point she gets to the point where you're ready to put her against outside of the training data and let her loose on the full data set to see how well she does. So we actually have, so the results are from 60% to 90%. Now let's talk about how this works cross-domain and where the real power is. So remember the Star Trek thing I was talking about, the English to Spanish, Spanish to English. So we use machine learning to teach Cortana how to translate English to Spanish. That was the first language we did. And that took 100% of the time, right? So let's say it took a month, right, for her to learn how to do English to Spanish, Spanish to English. So then we said, okay, we're going to do English to German. So when we went to English to German, she had actually learned how to do language translations. Even though it was a completely different language on the other end, she learned how to do it better. So it took 70% of the time for her to learn to create this domain map for translating English to German and German to English. So then when she went German to Spanish, she even went faster and faster and faster and faster, such that we think by the end of this calendar year we'll have most of the spoken languages, the majority of them, mapped out by the end of this calendar year. So this is what we call these domain or cross-domain. So you build a domain knowledge set of, say, English. And then you can then compare English to Spanish. And then that creates what we call a composite domain knowledge set, essentially a combination. It creates a new knowledge set, right? It's the mapping of those two knowledge sets together. And then you start mapping those to other domains, and you start spreading these out, and it becomes this big tree. The further down the tree, the more valuable that domain knowledge set becomes, because it's correlated with all this other data that you might not necessarily be able to figure out on your own. So it allows machine learning to do some amazing things and to get to predictive analytics. So here's some scenarios that we have. We have some pre-configured solutions right out of the box. So recommendation engines, forecasting, churn, anomaly detection. So think fraud right there. We'll talk more about that. I'll give you a specific example in a minute. Cortana is the PDA, the personal digital assistants, but we do visual, facial recognition. It does machine vision. Speech and text analytics. And the text, so it can take, for example, one of the scenarios I'll do is Cortana can do OCR on the fly, and then also reason against that to determine intent from the OCR text. Very powerful. Power BI, I don't know if you've seen that. It's a self-service BI dashboard, very easy to create. I'm not going to go through all these. The data stores, the big data, we have a whole host of these data lakes. When we get into the bigger solution, I call it the Sea of Cortana, because it becomes a massive repository. So as we go through some of the features that we have here, again, the APIs, these are open APIs that you call. Any application can ask Cortana, hey, tell me what you think of this. That's the how old am I, or twins or not. But we do that for all sorts of things. So let's talk about a know your customer scenario. This scenario was particularly built, this was actually a real world scenario where we were trying to figure out how we could combat human trafficking using payments information. And we started at the onboarding process. So this is, you gotta have to follow the trail as you go through. But if we, one of the things that we did is we took, at the very beginning, we inputted data from our front end by taking a photo of, just scanning the photo of their identification. Now, because we use vision, we can take that photo and we send it to Cortana, and we OCR the ID itself. So we get the key fields out of the data. So we get the name, the address, the color of the eyes, all that stuff out of there. But we also crop the actual physical picture of the person out, and then we submit that to the back end So the text is actually returned back to the front end, so you can pre-populate fields in your form as you're onboarding a new customer or you're filling out a form. There's no reason to re-enter it, but the thumbnail is sent for additional processing. And that thumbnail can go out and look at other data stores. It can say, hey, this is the person's name. This is their physical picture. Go look at all the known physical pictures of this. Somebody named this, and they'll look through Facebook and what's that company we just bought? LinkedIn. Just kidding. I had to throw that in there. But social media, other places, the press, wherever, particularly in press. So if you're familiar with KYC, a politically sensitive information person would be somebody that you would want to flag that would come through their press. So you would sit there and try to look for matches. And anytime you would find matches that show up and over and again that don't match the actual photo that you have, will trip an alert, right? It's like, this picture doesn't actually match who we think you might be. So that'll automatically raise an alert or an anomaly. That anomaly will then spin up a case for an investigator, so it'll create an entire BI dashboard just around this one case for an investigator to go in, and they'll get an alert, say, hey, a new case was raised. They can go directly to this dashboard, have all of the information about why this case was raised. There's no paper trail to follow. They actually have the picture, the metadata, and then the actual pictures of all the matches that came up against. In the demo, I don't have it available to me right now. We actually have a video of it we could show, but I can't get on the network. I'm not sure this thing. But anyway, but it actually, we do comical representations that use Homer Simpson as the picture. But it's a really unique way to automate the process of going through and using machine learning to do those types of things. So when we look at the scenarios, so fraud detection is one that's probably the most, and the credit risk as well. So we look at payments, fraud detection, and looking through payment networks. You can start to correlate payment, and the credit card industry is pretty good at this already. I mean, actually very good at this already. What they're not so good about usually is the notification process and the actions. So you get inconsistencies across credit card providers, whether it's a phone call, it blocks a transaction and somebody picks up the phone and calls you, which if you're overseas, or out of the country, you might not get that call and you might miss the sale. Some of them will send you an SMS message, which seems like a good thing to do, but the first time that happened to me in the States, I'm a Bank of America customer, and I trip the fraud alert all the time when I'm in Manhattan. It trips that fraud alert. They send me a text message, but the text message doesn't come. It's not. I can't validate it. It's actually from Bank of America. Because it comes from 404373 or something like that, and it says it's Bank of America. That says a fraudulent activity has occurred on my card. That in itself seems fishy to me. So I'm going to then pick up the phone. I'm going to call them and a more expensive servicing channel to figure out what the heck is actually going on. And instead of getting a more directed push notification that has identity baked in, that could go through a Cortana AI, so you could have Cortana actually inform you. So it could actually go to a native platform, so Cortana or Siri or whoever could actually validate, hey, this is actually from Bank of America. Your card has been tripped. Did you actually make these last transactions? Do you still have the card in your possession first, and did you make these transactions? So those are some of the things that you can do. And then again, the reasoning off of that data allows you to get to some interesting scenarios. So the predictive, all this rich data combined with all these other data points, whether it's collaboration data, business intelligence, communication channels that might happen, and then just, as you go around, if you have someone's identity, or you can, through most key indicators, you can figure out who someone is, you can start to do some interesting things. I just have a couple of examples. These are not directly correlarily related to payments, but you'll get the gist here. So here we have a wealth advisor for a financial institution that can ask questions and say, hey, Cortana, tell me the clients in my book of business that have the most exposure to X, where X could be, an earthquake, a natural disaster, China fiddling with their currency rates, whatever. And Cortana could then, instead of coming back with a search list, it comes back with a business intelligence specific dashboard right within the user experience that gives a heat map in this case that says, hey, Terry Adams is one of your customers that has the most exposure to China deflating their currency. And then right within that user interface, and again, this is the human interaction and connecting the dots, is they can connect and click on Terry and jump right into an activity and embedded and go right to the next best actions based on the question that you asked. So if Terry has a lot of exposure to the Chinese inflating their currency, what are the next best or recommended actions that you would suggest that I take and recommend to Terry? Model those out, loop Terry into a in-session Skype call, and take action to mitigate his risk. So when we talk about machine learning, you need to place it in a broader context. So if you think about payment scenarios, what are some payment scenarios that you would go through, whether it's a B2, especially in B2B payments? What are some things that you could do to surface into the user experience to make it a smoother transaction and to really improve people's experiences? Then you can start looking at things post, this is sort of out of looking at historical data. Once you have machine learning turned on against your data sets, you can begin asking natural language questions to Cortana. For example, show me, this is a financial advisor again that's looking at, show me the advisors that don't manage their book of business to a depth that actually shows that they're proactively engaging. In the wealth advisor business, there's lots of financial advisors have been around a while that have a couple of cash cows, and the rest of their clients they really don't proactively manage. And you have no idea what the opportunity lost is from an institution or firm-wide exposure that you have. This will allow you to get the visibility on that and track it, and then try to affect behavior within the user experiment by reminding that said advisor that he is the dead last in the active book depth list against his peers, to have some social competitive behaviors bubble up as well. And then the customer, an end user customer could put, I use US Bank here, and say, hey, Cortana, tell me when this happens. It could be payments related, it could be commerce related, it could be market related, and say, hey, tell me, in this case he's asking for when does the price of oil hit $40 a barrel? That is a leading indicator that Terry might do something if oil hits that price. Or it could be, tell me when the average price of this car goes to that, he might take action. That actual notification where he's asking Cortana that, and Cortana's going to remind him, that could bubble up if it's gone through in this case, it's going through the US Bank app. US Bank could then alert his advisor, say, hey, Terry's got a watch on oil at $40 a barrel. Do you want to be notified as well, so you can actually engage Terry proactively? That might seem creepy, but this is the world we're moving into, is where customers and people interact based on intelligent data, and those notifications can then be pushed to their mobile device for action to be taken. So as we look at, let's see what my time is here. I wanted to leave plenty of time for discussion. Good. So if we look at the analytics in action, we're trying to move from to get to predictive markets, where you can start predicting what's going to happen. And I'll give you a scenario of the C or Cortana that we're looking at right now. The PDA, bubbling up human interface, and then looking at other types of visual inputs and textual inputs to make things timely, fast, and available. So what I'm going to do is talk a little bit about some of the things we're doing and talk about predictive markets. So, and what's possible. So we can take, working with a market data provider and a news provider, I'm not going to name this said company, but you can probably make a very small leap and figure out who that is. You can take 50 years of historical news data that is already in digital format, and then take 50 years of tick data. So tick data is equities, commodities, fixed income, every pricing, and then throw that into the same data lake. So then what you can do is have Cortana go out and reason against and do correlation between news events and market shifts across all of the tick data, and do that over time while taking into consideration 50 years ago, news events, we didn't hear about them and markets did not react as swiftly as they do now. Now it's like sub-seconds, a news event happens and the markets react instantly. In the past, it would take days sometimes. So you have to figure out what those, and then you also have newer instances with the 24-hour news cycle, knee jerks, but what are the longer term trends for this tick data based on this type of news? So you could then make non-obvious discoveries. And from just some of the early testing that we had done, you would think that we did some really simple ones, like when hurricanes come into the Gulf of Mexico, or a typhoon hits in India or somewhere like that. What happens to the prices of certain commodities? What happens to equities of different types? How do the markets react? And we can look at the longer term, so go back 50 years. We have a lot of data that we can figure out from these natural disasters to figure out. And there's some obvious ones, right? So the price of lumber, rebuilding materials, those type of things, they're going to, supply and demand is going to make those go up. So how quickly does that work? But also you have, we found things that are non-obvious things. So you obviously think about insurance claims and insurance companies taking a hit, being able to adjust those things. But what we didn't necessarily think about were foreign exchange. So what happens in FX rates particularly when there's foreign aid going in. So one of the things that we discovered was foreign aid commitments made during natural disasters affect foreign exchange markets in weird ways. We can't talk specifically about the real examples, but for an FX trader, it is consistent over time so that you can basically predict what's going to happen in foreign exchange if a natural disaster hits in a specific geographic area. And it has to be one of significance, like the earthquake and the tsunamis, where lots of foreign aid had to pour in. Now that seems kind of evil and dirty, but you can either do one of two things with that. You can make a market with that type of information, or you can regulate it to try to prevent that sort of opportunistic scenario on those that have the misfortune of suffering from that. So with that, I'm going to kind of pause and open it up for discussion, questions. Anybody that's doing this now, be great.
I was going to say we're not doing this now. I'm still seeing Excel as the primary analytical tool in industry.
Yeah.
You know, in more advanced shops, you might see SAS getting used. But I'm just wondering what you think is standing in the way of commercialization of it. Like, is it too expensive, or because it sounds very appealing, yet I don't see anybody out there using it, and I think
Right.
big data has been a big disappointment.
Yeah, so if you couldn't hear the question was what's preventing people from doing this? No, you still see a lot of Excel, business intelligence through Excel, which we like to a certain degree, and Excel makes a good front end to big data in the back end. So what's been the big obstacle? There's a couple things. People have been slow to adopt the cloud for fear of regulatory scrutiny, so they don't want to put their transaction data in the cloud. That largely is going away, and that public data centers run by Microsoft and Amazon are more secure than the banks or financial institutions. So that's largely going away. And then the second one is so right now we have our channel called the Independent Software Vendors. So we have lots of ISVs in this space that are starting to build solutions and take them to market. That takes some time. The more advanced shops, the larger banks, are using this type of data and machine learning, but they're doing it in-house. So we do have an on-premises offering as well. It does limit you, though, to third-party data sets that you can use without having to purchase them. So a lot of them purchase them at a much higher price from a Reuters or a Bloomberg, for example, instead of using a shared instance of that data in the cloud. So I think it's just sort of a matter of time. I think big data has largely been, was overhyped at the beginning because we didn't have the machine learning tools to really reason over it, geared to work for those types of data sets. So it's taken us some time to get the machine learning algorithms to run and then to run at scale. That's the other thing. And within Azure, we have millions of CPUs that we use in a very elastic sense for workloads like this, that we can really focus like a laser to learn things. And once you've issued it over, those resources go elsewhere. But we'll continue to see Excel be important part. So Excel is tightly tied to Power BI. So you can take any Excel spreadsheet and upload it to your Power BI. So you can have your own personal Power BI, you can have a company-wide Power BI, and it can create a dashboard for you based on your Excel spreadsheet to give you visualizations that you may not necessarily be able to create in Excel or have the skills to. It becomes much more accessible for the average business user of Excel to upload Excel spreadsheets to Power BI and then create your dashboard. So if you haven't done that yet, it's free. You can sign up for a free trial of Power BI, take your spreadsheet, you can upload it, and create your dashboards from that. Question? Yes. Yes. So the question was, how do blockchains play into this? So it's a gold mine, actually, and it's the perfect scenario because of we have the historical ledger of the transactions, we have the hashes of the data that we can then correlate. So we are building services. I published a paper on Wednesday about our Bletchley platform that talks specifically about what we're doing. We are not going to be, so we're building the tools, these same tools that I talked about for distributed ledgers and blockchains, that you'll pull that same data set and it will be a master index, if you will. The data factory will pull blockchains at your interval, because blockchains, if you're not familiar with them, they're not really good data stores to crawl against. They're kind of slow. So you want to make sure you call the transactional data out, pull it into your data lake, have it in the background, correlating the data to the reference data, and then we know it's going to be a gold mine, not just for, so all of our customers that are signing up for Bletchley, that's the thing they're probably most excited about, is Bletchley is the code name for our blockchain stack at Microsoft. It's the open platform. So you can use any kind of blockchain that you want, but it's the enterprise sort of capabilities around it that surround the blockchain that'll let you do more advanced things like that. Question over here. Yeah, so the question was, what are the indie segments within financial services that are doing machine learning very well? So the credit card industry has gotten pretty good at it, detecting fraud. Sometimes they're too good, or they have a lot of false hits, which sometimes can be expensive. depending that the expense of the false hits though is more of a not of their machine learning platform, but of their delivery of the message that something irregular has happened to your account. How do you want to handle it? That's the expense. So that would be one of the first ones. The second is in obviously it's in trading. So we're seeing this a lot in capital markets, a lot of in-house trading. So a lot of the high frequency trading algorithms are actually using machine learning. Most of them are doing it on iron or compute on premises. We do have some high frequency trading that are looking at hyperscale machine learning engines. But when you get into high-speed trading algorithms, speed of light becomes an issue. So I don't know if you read Flash Boys, but that becomes a significant issue. So that's one of the barriers for them to really go to the hyperscale. I think we're seeing, we are actually participating with some partners building out AML, KYC solutions that involve anti-money laundering, and machine learning to detect anomalies, to reduce the number of false positive for SARS reports, but also having some sort of certification for audit from a regulator, so that it's not such a daunting task. How many of you work for banks? Okay, and how many of your banks, how much has your compliance department grown over the last 3 or 4 years? 500%, 1,000. My sister works at Wells Fargo, and she's in HR. And their compliance has gone. I don't know if it's like 8,000 now. It's ridiculous amount of people, and it's not a great job. I mean, if you've ever anybody work in compliance, it's miserable. Nobody really wants to do that work. So anyway, we're hopefully going to try to eliminate that with machine learning and blockchain combined. So blockchain and so it's the combination of these technologies. Them in isolation, they really aren't that interesting. But when you start to combine blockchain, machine learning, big data, that's when you start going. You have that aha moment, and hopefully you guys will have that aha moment and take it back to your organizations and say, we should look at this. And you don't have to be a technologist to understand. If we can have access to all this data and do this machine learning and then have this immutable index of transactions and we combine them together, we can fundamentally change our business. So it's a very interesting space. Yeah, so Robo Advisors. Yeah, we do. So we do have a couple of startups that are using this, and that's just it. They're startups. Some of the bigger banks are played around. I know Citi has done some stuff, and but the Robo Advice, you at some point, what the Robo Advisor just says, do index funds. Done. That's all you really have to do. But yeah, I mean, we're seeing those, and they'll get more sophisticated. So the one of the example I talked about, the FX on disasters, that was from one of these startups that we were working with, which is one of those unexpected things that you find, and it's not necessarily leave a good taste in your mouth. The black box what? Mm-hmm. Right. Oh. Okay. All right, last question. So the best way is we have to do better at marketing to make it more accessible for executives. And we're working on that. And it usually has to be visually done and to provide those tools So we do have some good assets up on Microsoft.com under Cortana or machine learning that you can use to pitch to your business leaders. With that, I guess I'll let you guys scurry to wherever the next thing is. Thank you.